while they're setting up the microphone. If you guys enjoyed the biryani, make some noise. If you guys enjoyed the dal makhani, make some noise.
Hello.
All right.
Hello.
Deepak, are we ready?
Yeah. Yeah. Hello, guys. Good afternoon. Today, I'm going to share some of the challenges we faced, while optimizing the workloads, right? And from the continuing to the Shivnath's note, right? Any issues? Yeah. So continuing from Shivnath's note, right? You have been aware of now what is data plus FinOps, right? Now what I'll cover is the double click on the insights part, right? How do you optimize that, and how it is a difficult problem to solve, or to optimize your workloads, personas, right? We already have covered personas. I'll just refresh them, and then we'll cover the challenges to build solutions for data FinOps. Okay, and then I'll cover how do we build the solutions around it, and then. Even if you optimize the solutions, right, another challenge is a different problem, actually. So I'll just also cover the challenges to operate and govern, phase, so that how that solutions can be actually, get a realized value from that solutions, okay? And then the solution phase, that what are the FinOps needs for the different personas, right? There are data architects, business unit leader, right? What data architect needs is how we can speed up the things by designing, the data pipelines, right? How do you design, how do you optimize the storage, and end-to-end SLA is met, right? The second problem for the business unit leader is, how do I govern the cost, right? The person knows, my app where and optimize my app. So each persona, and same for the data operations, right? How I can troubleshoot it faster, right? So these are the various different problems for different personas, right? You need to have a solution for, targeted to each of what part I will cover is in the inform phase, right? You might have already seen from the previous talks, right? That the observability, that you track the data, right? Data from the different workloads and clusters, whatever entities you have. This phase mostly I'll talk about how do we, and then, right? How do we make them actionable and get one of the, I'll walk you through an example. So this is an example job, right? This job ran for like 13 hours, 34 minutes, 34 seconds, right? With some optimized solution, right? You can come up with some recommendations. I hope you can see the text, but I'll just read it for you. There is some recommendation for driver type, right? Use solutions, and what challenges we do. Grouping may be, if I tune this one SQL, you can find out so this is like most important factors for that variance, right? One is the input output. They run with 1 terabyte of data. So we have seen the customer running the same pipeline from 1 KB to 1 terabyte. So now if you have 1 terabyte of data, it is the same run, no changes in the job, but due to behavior of the input and output data, right? It actually, is difficult to, suggest that particular recommendations. Second thing is you can have parallel jobs running due to the parallel applications. You can have parallel stages which are independent, and within the stages you have tasks, right? Different tasks. Now they can also vary. Now, for example, if your input data is just 1 MB, and then your Spark may optimize it to and broadcast has joined, because for that case it was a better plan. Now tomorrow the data was so used that it used sort merge join, right? So your query plan changes every time. It is not easy to calculate the resource utilization for that particular point, because the behavior of the query plans and the internals changes. So this is one of the challenge, to optimize the particular Spark job. Sorry. Then comes the parallelism, right? Now, when you say you cannot straight away downsize the machine even if the utilization is at 10%. Okay, why? Because there are various levels of parallelism based on the input data. Let's say you are reading from Parquet, right, which has like 1,000 row groups. So there are 1,000 partitions coming to that particular Spark job. If you downsize that to the 16 core, right, what will happen is the parallelism will change. Eventually your duration of app will change. Okay, that will affect the stages, the jobs, and eventually the job may run, very long time, right? And it may cost you very high instead of saving the cost of downsizing the node. So the parallelism is like two side, right? One is driver side. So some developers, do driver side parallelism. They use a thread pool and, invoke multiple Spark jobs within the driver, right? So that you can optimize the utilization. Now, to figure out, what jobs can be run in parallel, because, it is also one of the challenge, to in the optimized phase. Execution parallelism I already talked about, right? So regarding partition, your partition may vary, okay? Due to that, the parallelism, if you downsize a node, you cannot, so your parallelism will not have enough code in this, because every platform has their own algorithm of auto scaling. Now, let's say you set some mean and max value, right? In the Spark, right? You need to scale that. Let's say, for example, Databricks scales to the max node, but they are not. The auto scaling behavior also has an impact because their auto scaling windows are different than the application scaling windows. The other thing is the variety of the distributed file system. So you are reading from S3, you are reading from DBFS. Now the underlying, they are like somewhat similar in the concepts, but their features like parameters may vary based on the implementation of DFS. Okay, so it is difficult to get. Then let's say you use the same app with different DFS, like from S3 or from Blob Store. You just have changed the storage type. And then the file listing, like in the metadata listing, the lookups, right? It takes time, to look up, and based on the implementation, it actually varies. So here are some examples, right? DBFS, S3, Azure Blob Store, right? So even if it is DBFS, it is like basically a fused file system. It writes to local and then does a fuse call to remote. So that's one of the challenges, right? And some of the distributed file system uses same cluster resources. Okay, even if your business logic or the Spark logic is different. Okay, now that HDFS is using the same resources, so the resource utilization is different for app, is completely different for the SDFS and S3 if you use the same app. So that's the point basically. So second, another important aspect of challenges is like the patterns, right? The application pattern, right? If whether your application is one time you can expand the disk. Okay, now the throughput actually varies when you expand the disk, and the expansion of the disk actually is in a dynamic based on some parameters like how much storage you use and that kind of thing. So that actually affects the throughput. So drastic difference in the throughput. So yes, within the stages also you have variance in the timing. Okay, so yeah, so that is also a very important factor to consider. So like disk type NV, if it is an NVMe, right, devices or SSD devices. Yeah, some of the Azure Databricks instances has L3, 256 MB L3 cache. People may not aware because within the Spark world, right, that you have some shuffle mini stages which does a merge sort kind of thing, which L3 caches can be used there. That kind of instances can be used. Then you have like auto-scaling storage. Actually, I already mentioned, right? The auto-scaling feature of the Databricks. Then there are also challenges when you do a vertical scaling versus horizontal scaling. So you want a 32 core machine. So you can have like 4 core into n machines, or